All right, welcome friends. This is a live session on containers, what next? And we have Anthony Nocentino from Nocentino Systems with us. And over to you, Anthony, take it away.
Cool. Thanks, Amit. Good morning, good afternoon, good evening, wherever you are in the world. Thanks so much for attending. Thanks, Amit, and to the team at DPS for having me this year. It's been fantastic. So this session is called Containers, What's Next? So basically, if you've been working with containers for a little bit, this is what I think you should do next. That's kind of the nexus of the session. So here's my information. I'm Anthony Nocentino. I'm a consultant and trainer, founder of Nocentino Systems, and I specialize in system architecture and performance. I've been a data platform MVP for a couple of years and also a friend of Redgate for the last few years, and they're a sponsor of this wonderful event. Please check them out in the conference hall and the sponsor in the booth, please, or the virtual booth. There's my contact information. It'll show up again later, but please feel free to reach out to me via email or Twitter if you have any questions about today's session. I blog pretty frequently at my blog URL there, and I'm also a Pluralsight author where I have tons and tons of courses on Kubernetes and on Linux and on SQL Server on Linux. If you want access to those courses for free, hit me up via email and I will give you a free trial access code to get into that content so that you can dive a little deeper into containers and SQL Server on Linux. So for today, like I said, it's kind of like what's next. Like you've worked with containers for a little bit, you know how to start and stop a container, but what are the things that you need to do when you want to start using containers in more advanced scenarios? That's kind of the coverage for today. And so we're going to zoom in on kind of the underlying details of storing persistent data in containers. So you can kind of understand where data is really stored when you're working with containers and how you can work with containers to provide persistent data into your applications. And of course, today we're going to be talking about SQL Server. Now, the next topic that we're going to get into after that is this as a security topic, non-root containers. If you've worked with SQL Server in the earlier versions inside of a container, it ran as root. That wasn't exactly the best security practice. And so we'll talk about why that's bad and also how to move on to non-root containers and how it's configured in SQL Server 2019. And if you want to configure it yourself and build your own container, why that topic is super important. So that's the third point that we're going to get into today. That's going to be building a custom container image so that you can work with maybe some additional features or configuration in a base image that you can then deploy over and over again in your environment. Then we'll go on into talking about how do we get data into our containers. So that's great. We can stand these things up fast. But how do I get data in there either manually or automatically at deployment time? And so we'll talk about that as well. And then get into some general container performance concepts, what it means to run multiple containers on an individual host, and also what to look at from a performance standpoint, both at the host level and inside the container. And so let's get started. We're going to start off with how containers store data. And so when you're deploying an application inside of a container, right, that's the unit of deployment, right? The container is the package that you deploy. And the thing that you deploy is a read-only copy of your application in this thing called a container image. And so when I deploy that container image and I start it up, I run it, whatever it is, in addition to that read-only copy of the container image, as data is changed, it's going to be written into this thing called a writable layer. So new files or any modifications will be written into this writable layer. Now, your container runtime does the heavy lifting for you and merges the read-only container image with the writable layer and presents back to you or your application a single file system, right? And so your app sees these two units as one thing, as one single file system, which is great for your application. But as you're working with your application, this writable layer has the life cycle of the container. So if you delete this container, that writable layer will go along with it. And so you might be thinking, well, I'm a data professional. My job is to keep data around. And this kind of paradigm is incongruent with doing that, right? If I delete the container, my data is gone. That's bad news. So let's talk about how containers can store persistent data, right? And what we're talking about here is going to apply to Docker or Kubernetes or any container runtime, really. So this is kind of the concepts. We'll talk about the implementation details for Docker specifically when we get into the demos. So when we're talking about storing persistent data in containers, so we still have that same deployment paradigm where we have a container image, a writable layer, and the container runtime is doing the work of presenting a single file system back to our application. But what we can do is we can attach a volume at a particular location inside of the file system in the container, right? And that volume is positioned at a particular location in the file system, like var opt MSSQL, if you're running SQL Server. You can also, of course, position multiple volumes inside of the file system if you need more advanced scenarios, but we're going to focus on a simpler scenario right now. So as data is changed in the location that that volume is attached to, like var opt MSSQL, the data at that file system location will be written into the volume. Now, the rest of the container data that's not written to var opt MSSQL or wherever you attach that volume to will still be written to the writable layer. So that will still be, let's say, volatile or non-persistent when I delete the container. But when I delete this container, the data that was written into that volume will stay into that volume. So I can come back later and attach another container, right, to that volume and get access to that data again. And so that's how we can add persistency to our applications, specifically today's SQL Server, when we're running them inside of a container. So this container starts back up, the SQL Server process starts up, it looks in var opt MSSQL, it sees all of its configuration, it sees the master database and the user databases if they're in that same volume, and just goes about its business starting up like it would any other time. The key here is that that volume has a life cycle that is independent of the container. I can delete the container and throw it away and bring back a new one and attach that volume. And so that's how we're able to get that persistence. You can also be able to move between versions of SQL Server. I can upgrade SQL Server from between CUs or even to major upgrades using this same deployment paradigm. And so let's look a little closer at how Docker handles data persistency specifically. We're going to work a lot with Docker data volumes. And Docker data volumes are a way to have Docker manage the volume allocation and location for you. Now, generally, when you're working with Docker data volumes, generally, it's going to be a local storage on the host. And that's what you'll get by default if you just create a Docker data volume. And again, we'll look at the syntax for this in the upcoming demos. So you generally get local storage on the host, and that's going to be allocated from the physical machine or virtual machine up into your container image at a configured location inside the file system, var opt MSSQL for our demos today. But you do have the ability to enable scenarios with remote storage with what are called volume plugins. In addition to volume plugins, you could also just have remote storage at the operating system level. And so what a volume plugin will do is go and basically orchestrate the access to remote storage. And that's going to happen inside of the container runtime. But we could also just have remote storage attached into the OS and allocate data from there. When I say remote storage, things like NFS or Fiber Channel, just any other way that I would attach storage to that base operating system. Now, what you can use Docker data volumes for, in addition to data persistency, is I could also pre-populate content. I could put backups inside of these directories or inside of a volume, or I could put database files inside of a Docker data volume and expose that into the container and either run a restore from it or attach the databases. And we'll look at how to do that in the second part of the talk today when I talk about getting data into containers. So yeah, so we can attach backups and content into a running container, and then we can run operations on those since that data is accessible inside of the container. Again, it could be backups, it could be database files themselves. Got a little ahead of myself on the bullet points. So in addition to a Docker data volume, which is a allocatable resource from the container runtime from the base OS, I could also use a technique called a bind mount, which is commonly used to basically short circuit access from inside the container to the base OS. And so what we'll see here when we use a bind mount is we'll actually see the underlying operating system of the file system. And so this is a common way to either bring backups into the picture or oftentimes like scripts or something like that to have access inside of a container image. But generally, we're going to be using Docker data volumes, which will give me an allocatable resource from the underlying base OS by the container runtime. Storage is a pretty deep topic. I'm just kind of glossing the surface here to kind of show you how we can leverage it inside of containers. But check out that link there if you want to get more into things like volume plugins and the various ways that you can allocate these resources, volumes, both Docker data volumes and bind mounts. So the next topic that we're going to get into is non-root containers and understanding why we don't want to run containers as root. So the first generation of SQL Server running in containers, so 2017, and I believe the first couple of releases of 2019, the process running inside the container ran as root. And this exposed the underlying operating system to a security risk for two reasons. One, Docker commands are privileged. So when you type Docker something at the command line to instantiate a container, that's a privileged operation. So you can pretty much do whatever you want. And in conjunction, if you combine that with the fact that Linux uses user IDs and group IDs for permissions, that's where you start to color in the picture of what the security risk is. And so let's look at this graphically. If I allocate a container and I deploy a container, and that container is running as a root process, I can attach any arbitrary volume from the underlying base operating system because Docker commands are privileged. That process that's running inside the container is now running as user ID 0 if it's running as root. And since Linux uses user IDs and group IDs to manage permissions, that process inside the container running as UID 0 will then pretty much have root access to whatever is exposed into the container. So you could do whatever you want to the base OS, right? And that's a huge, huge, huge security risk in most systems, because now I can change configurations, I can mount data volumes that I might not have access to or shouldn't have access to. And so we need a better way, right? We need a better way to manage this type of deployment. And that's where non-root containers come in. What we're going to do is we're going to run SQL Server, the process that's inside of our container, as the username MSSQL with the user ID, which is conventionally going to be 10,001. It can be any arbitrary user ID that's not 0, but you'll see it most commonly as 10,001 in configurations. Now, the Microsoft official images require no configuration. Like if you pull a 2019 container today of one of the more recent versions, that container image, when deployed, will run as non-root. So that's super good. But what we're going to look at next is how to build our own container image. And so when we build our own container image, we're going to need to run some tasks as root inside the container to build the container image. But before we start up SQL Server, we're going to switch to a non-root user, MSSQL, so that our application runs as a non-privileged user. And we'll talk about those techniques in our upcoming demo. So that leads us into the next part of the talk. It's, well, let's create our own container image. I'm going to walk you through the process, the general process of how to create a container image. Then we'll look at some SQL Server specific stuff, and then we'll look at the code to do that. And so a container image is just your app, right? It's your application. It's any of the libraries that it needs, any of the file system components and environment variables that you need to run your application. And today we're going to focus on SQL Server. A running container image is a container. Container images are stored in container registries. So Docker Hub, Azure Container Registry, or even your own internal container registry. And that's where you'll put a container when you want to store it or share it with someone else, right? Or even get it ready for deployment. Docker files are what defines what goes into the container image. And so let's look at the process of building a container image and storing it in a registry. So if I want to create a container image, I'm going to write a Docker file that describes what I want in the container image. And that's going to be my application, anything that it needs, binaries, libraries, configuration, etc. Once I'm ready, once I write that Docker file, I'm going to do a Docker build. That's going to make a binary package or a container image on my local system, on my development workstation, that I can then start containers from. And that's what we're going to do in our demos today. We're going to write a Docker file, we're going to build a container image, and we're going to run that container on our local system. But if I wanted to share my custom build with you or have it in an enterprise deployment, I'm going to push that container image into a container registry. And then from there, other users or even my deployment systems or my container orchestrators could pull that container image for deployment on their systems, right? And then they would have an exact copy of what I just built. And that's kind of the magic of containers, because that concept of exact copy is really, really, really valuable. And so let's go and talk about why. Like, why would I want to do this, especially in the context of SQL Server? Well, Why would I build a container image? Well, this is probably the biggest reason. I can build once and deploy many. So I write that container image, or I write that Docker file, I build that image, I bake into the image all of my customizations for my apps. Perhaps I need specific settings. Perhaps I have certain standard best practices for my deployments. I can get that all built into a singular image that I can deploy over and over again and also maintain over time. Then on top of that, I get control, right? Rather than using the official images for Microsoft and just having to take it as it is and how it's configured, I can craft this image for exactly how I want and get that deployed into my environment. And then finally, security, and similar to control in the sense that I can control when things change inside of the image. So if I need to patch a particular library, I can do that. If I know there's a vulnerability that I want to handle right now and not wait for a release from Microsoft, I can do that, right? And so this puts that control and security back into your court from when it comes to how you manage that in your deployment. And so let's look at SQL Server specifics for building a container image. We're going to look at the logical process here, and then in the demos, we're going to look at the code. So I'm going to break it into 4 big chunks when we're writing a Docker file and building a custom container image inside of SQL Server. We're going to set up the environment. We're going to install SQL Server. We're going to configure SQL Server, and we're going to build the container image. Those are the big steps, right? Let's look at each one of these in more detail. In the setup the environment section, what we're going to do is do things like add users. So we'll add that MS SQL user with the specified user ID so that later on we can tell our container to run as that user. Then we'll add any Linux package repositories that we're going to install software from. So by default, the Microsoft repositories for apt aren't included inside of the Ubuntu image. And so we'll add those repositories so that we can then install packages from them. Oh, I do want to call out that for today's build, I'm going to use an Ubuntu image. You could use Ubuntu or also Red Hat Enterprise Linux for the same process. It's just slightly different than the package installation tasks. So once we have the environment set up, we've had the users and the repositories configured, we're going to install SQL Server just like we would install SQL Server on any SQL Server on Linux implementation. We'll use apt to install the package msSQL-server. In addition to SQL Server, I'm going to want some tooling inside of the container image itself, and we're going to install the MS SQL tools so we get things like BCP and also SQL CMD. In addition to SQL Server, I can install other packages. So for example, machine learning services isn't part of the base installation package for SQL Server. So I'd have to install an additional package there if I needed that. Now, once I have everything installed, I'm going to configure SQL Server, and we're going to use MS SQL Conf to do that. What MS SQL Conf is a command line utility inside of Linux that basically exposes any of the configuration parameters that you need to configure your instance. So analogously, on the Windows side, we had SQL Server Configuration Manager, but we don't have that on the Linux side. We have MS SQL Conf to configure those attributes. Additionally, we can inject configuration either at build time or at runtime with environment variables. And that's a way for me to expose and configure things inside of the container at runtime or at build time, but gives me the ability to inject that outside of the build if I need it. Now, once we have that all laid out, we'll build the container image. We can run it locally or we can push it to a repository. I do have 2 links here for you. The things that you can configure with MS SQL Conf, that's at this link here. And the second link there is the things that you can configure with environment variables. Roughly speaking, I'll say anything that's like really persistent that you want baked into the image, do that in MS SQL Conf. Anything that you need to change at runtime, do that with variables. And that's kind of, say, roughly speaking. Of course, there's different ways that you can manage both injecting configuration at runtime with either of these techniques. So let's do it. Let's go ahead and dig into a Docker file, create a custom container image, configure SQL Server inside of our image, and then deploy. Let's jump over here. There we go. All right. So I've already built this image, but I'm going to kick off the build with Docker build -t and it's going to build an image named SQL demo dot. And that is going to, let's walk through a couple of things here. I'm in the wrong directory. Let me change into the right directory. So in this directory, I have a Docker file. Inside that Docker file, which we're going to look at in detail in a second, is all the instructions to build. I'm going to kick off the build because it can take a minute to get running. So that is going to build the container image for the Docker file in the current working directory. That's what that dot indicates right there. And the image is going to be named SQL image demo 1. What did I just build? Let's check that out. So we'll walk through the details of this Docker file, but it's the process that I just described in the presentation. We start off with configuring the environment. Our base image is going to be Ubuntu 1804. So we're going to have an 1804 image, and anything that we do after this is going to be built on top of that. And so that's what we're configuring. We're going to add a user. So here's the syntax to add that MS SQL user with a fixed user ID of 10,001. The first part here, we see we're going to install some packages that allow us to go and execute some curl commands, basically. And so the curl command allows me to pull files from the internet. What files am I going to pull from the internet? Well, I'm going to pull the repository information for the 2 Microsoft repositories that I need to install applications from, one for SQL Server and one for the tools. And so that's what this line of code does here. I'm going to apt-get install SQL Server, MS SQL tools, and Unix ODBC dev. Now you see this kind of crazy syntax here where I'm combining several commands into one instruction. So this is a run instruction. So it executes a command on the container image. I combine these together to reduce the number of steps in my container image build, which is effectively an optimization. And so we'll group together like commands. And so here I'm grouping all of these installation commands into one step. Once that's done, I'm going to clean up some package metadata, which will help me reduce the size of the container image because it's getting rid of the things that it doesn't need. The next part I need to do for this custom container image build is I need to lay out some file system locations for SQL Server to use. And since we're running it as non-root, I need to create a directory, and then I need to change the ownership of that directory so that the MS SQL user has control over that directory. And so that's how we did, what that step does there. Now that we have SQL Server installed, we have a file system location. Let's go ahead and configure SQL Server, and we use the MS SQL conf tool for that. So here we see MS SQL conf set SQL agent enabled equals true. MS SQL conf trace flag 3226 on. So here's 2 examples of configurations that I want inside of every container image that I build. And so every container that I instantiate from this image will have those settings. What settings can I configure? That's where you go back to those links that I referenced in the presentation, and you can see the varying configuration points for SQL Server on Linux. We'll expose our application on 1433, and here's where we switch our user context to MS SQL. Anything before this ran as root, which is fine. We're installing packages, we're adjusting permissions, we're creating directories and things like that. But now we're going to switch to MS SQL, which is our non-privileged user. And then the final step here is the command instruction. That's the program that this container will start when it's deployed. And so there we see, we're going to call opt MS SQL bin SQL Server. So that's going to start up a non-root instance of SQL Server when I deploy the container. So we just built that container together, and what you have at the bottom here is the output of that build. And you can see each step that it gets executed against the container image. Now, I pre-built the container image just for speed. This usually takes about 5 or 6 minutes to get everything installed on my system. But your output will look a little bit different because it's going to actually execute each one of these commands. So you'll see things like apt installing and updating. So you'll see a lot more output than I saw here, but I pre-built this just for speed today. So you see a successful build, you'll get an image ID. We tag it with a meaningful name. So here we see it's SQL demo or SQL image demo 1. So let's run a container from that. So we do that with Docker run. We're going to inject some configuration with environment variables. That's one of the ways that we can configure a container at runtime. the two things that we absolutely need are to accept the EULA and then to inject an SA password. We'll give our container a name, and we're going to allocate a Docker data volume named SQL Demo 1 and mount it at var opt MSSQL. And our container is going to listen on the base OS. So I'll point applications at that port there. And here we're going to run our custom container image that we just built together. Fingers crossed that I get a container. This is the first time I'm doing this session because we wanted to have all the new stuff for DPS. So here we go. Docker PS is the container running. Looks good. It was created 8 seconds ago. It's been up for 6 seconds. It's listening on all IPs on 31433. Let's check if I can connect to my container. A little bit nervous right now. I'm going to drink coffee and act cool. So sometimes it does take a second for SQL Server to come up. So there we see login failed. There we go. So that's just going through the startup process. It wasn't quite available when I hit it the first time. Excuse me. So by default, the server metadata inside of SQL Server will use the container ID for the server name metadata. And so if I do a Docker PS again, you'll see the container ID ended in C2F. That's what gets inserted into the container. We'll talk about how that's meaningful and why when we get into the later part of today's session. Let's take a peek at what version we're running, CU8. So let's go inside the container a little bit and look around just so we can see what we did, right? We did some stuff to configure our image, and I want to make sure that that's all there. So inside the container, I want to call out that we can see SQL Server is running by itself. Like it thinks it's the only thing running on this operating system. And the architecture of SQL Server will always have two separate processes. And this process here is going to be the one that actually is doing the work inside of SQL Server. The parent process is a watchdog process that does some stuff to manage the environment for you. Now, we made some modifications with MSSQL conf, which are going to be persisted in this location here. So we can see how SQL Server sees that configuration. So those commands that were executed during the build, write this file out. This file is read when SQL Server starts up. I also want to show you how environment variables are set. So if you type env, we can see we have at runtime, the process can see our SA password and also has our EULA. And so any environment variable can be exposed and read by processes running in this application. If I look at our data directory that we created, we can see that it's owned by the user MSSQL for data, log, and all of the other parts of the instance. And if I look inside of data, there's our data. This data is actually stored in a data volume, although SQL Server thinks that, or excuse me, the container thinks that it's all at this location. I do want to call out that I forgot to mention when I did the process listing. Let's go ahead and run that process listing command one more time. Running as the user MSSQL rather than non-root. All right, so let's hop outside of the container and look at where our data is actually stored. So we allocated a Docker data volume, and that Docker data volume is by default going to get allocated at this location here. So on my physical system, this is where my data really, really is for the stuff that's in the data volume or the things that are attached to var opt MSSQL. A second ago, you saw I did a directory listing inside the container on that data directory. If I look inside of this directory here, we see the base directory for var opt MSSQL. There's that data directory inside the container, but that's exposed inside the container, but this is where it physically lives on the base OS on this Linux system that I deployed the container on. So when we remove that container, our data is still there, right? If I go back and I do a directory listing, there's our data, even though the container is gone, right? Docker PS -a, there's only a hello world container available here, not our SQL Server container. So I could deploy another container on top of this and get access to that data. When I delete the volume with Docker volume RM SQL data 1, that's when that data goes away. So if I look inside here now, that's gone, right? And so that's how we can see how we can decouple the data from the runtime of the container itself. So cool. Covered a lot in that demo. We built a container together as non-root. We configured SQL Server inside that container image, and we deployed a container from it. And so let's talk about getting data into our databases, right? So now I have this thing that is kind of custom built for my environment, but I want to go further, and I want to be able to maybe either manually or automatically get data into these databases or into these containers. And so a common question that's asked is, should I put databases inside of the container image? And the answer is no. And the reason why is there's really twofold. One is the size of the database will become part of the image. So if it's if it's just maybe like schema or something like that, all right, maybe you can make the argument there, but then it's still inside the image. And anytime there's a schema change, you have to change it. But it's anything substantive, like of any size, that data will become part of the image. And so when you deploy, guess what has to get dragged into the target system, right? All of the data. And if you do that multiple times, then you can see how that'll get pretty heavy in a deployment. But even crazier is this. On container startup, so I deploy a container. What's going to happen is anytime a data is changed inside the container, it's going to get copied into the writable layer, right? Or into a volume. So that copy on write instruction, that's what CAL stands for, copy on write instruction. So when data is changed, it's going to make a copy. If that's anything of any size, like, I don't know, 10, 20, 30 gigs, anything, it's going to make a copy of that file for the changes. So now I'll have that 20 gig file in the container image, and I'll have another copy of it in the writable layer. And that can take some time to start up your instance. In fact, last week I was doing this and it caused a non-yielding scheduler and just crashed the SQL Server, which was great. Not really. And so that's another reason why you don't want it inside the container, because it's a waste of space, but also it's just not something that can be managed very easily at deployment time. And so what we're going to want to do is either restore or attach databases at container startup, right? So I'll deploy, and then I can either manually or automatically restore or attach databases. And we're going to walk through some automated restore examples today. But a good friend of mine, Andrew Prusky, on GitHub has blog articles and demos on doing attachments too, if you want to check that out. So we can do this either manually or automatically. And what we'll do is, or we need to make sure, is that databases, the ones that we need, right, whether they're going to be restored or attached, are available to the SQL Server process inside of the container. And you're probably used to this from a Windows standpoint. If I ran a database restore, the SQL Server process in Windows needs to be able to read the database files on that target system. And so that's kind of what we're doing here, is we need to make sure that the databases that we want to restore or attach are accessible to the process running inside of the container. And then we'll run our restore or attach process from there. And so we'll use volumes for that, either bind mounts or Docker data volumes in today's demonstrations. Those volumes can be local or remote. And using this technique gives you the ability to seed larger databases in containers without having to drag that data around. So let's see that kind of logically or graphically here on the right. So if we use the normal deployment paradigm of deploying a container and attaching a data volume for our databases, well, what we can do is we can just attach another data volume. And inside that volume is our backups or our databases that we want to attach, right? And so inside of there, SQL Server can go read the data that it needs to perform the operations. And so we'll expose those backups or databases at a fixed location in the file system. I think in our demos today, I put them at /backups, right? And then for our demo, we're going to run a restore against the stuff that's in that data volume. Now, what's cool about this though is I can share that data volume across other containers. So here I can deploy another container, SQL Data 2, and I again can share the stuff that's in that data volume into that other container. And so that can be large backups or whatever it is inside of there. And that could be local or remote storage, right? That could be in a remote fiber channel array. That could be NFS. It doesn't have to be inside of the actual host itself. And so let's look at how we can do this automatically, right? So if I want to automatically restore a database at the time the container is deployed. So that CMD instruction that we saw a second ago, command, was used to start SQL Server. Well, what if we just tell it to run a script, right? And so we say, hey, run this script. And inside that script, we have some code that will go and test to see if SQL Server is online inside of the container, right? And so we'll use SQL CMD for that. Hey, SQL, because you saw a second ago when I started up SQL Server, it took a second for it to respond correctly, and then it was up. And so that's what this loop does, is it checks, hey, are you up? Are you up? Are you up? Oh, you're up. Now run the script to go and execute the restore or the attach, right? And that's kind of the process there. And so let's go ahead and see that in action. We're going to restore a database inside a container, both manually and then also with this automated process. There we go. Okay. Switch over to demo 2 and let's grab a Docker file. So since we are, whoops. Okay. If you haven't heard the stories, my laptop literally caught on fire on Tuesday during my pre-con. So I'm on a backup laptop, so things are a little bit sluggish. So to do this, we need to build another container image, right? And inside this container image, since we're going to change that command instruction from SQL Server to this other instruction that executes a script, we need to make a change. But what is the same is pretty much every other part of the Docker file. So I'm not going to go through all of this except the things that have changed. Here I added another directory. So in addition to creating var opt MSSQL, I'm also creating this scripts directory, which is where my scripts will live. I'm going to adjust the permissions of that scripts directory so that SQL Server has access to those. And then we're going to copy the scripts from my local system. So copy from the current working directory of my local system into the container image at this location. So let's look at where those live on my underlying OS here. So this is my build system. So if I change up a directory and go over to demo 2, here we can see I have a scripts directory. Inside that scripts directory are the restore scripts for what I want to do. It's a script to drive that loop, and then the actual restore script for my database. If I look inside those scripts, we'll see, where is it? Here. I'm going to go through this logically, not line by line from a code standpoint, but just to describe what it does. We have a loop here that runs SQL CMD and checks to see if it can just run an arbitrary query, just select from sys.databases. It's using that environment variable that's available in the image to inject the SA password to test. Once it gets a 0 exit code, it breaks. If it doesn't get a 0 exit code, it sleeps, loops again. Once it breaks, it runs our restore script. And so we use SQL CMD for that. And it calls the script in that scripts directory that we're about to copy in when we build our container. Now, this is a pretty simple case where I'm just executing a simple database restore, but I could have it create databases, run bulk copies. I could do pretty much anything I'd want at this point in time. I could call init scripts to populate data, or if I have a collection of T-SQL scripts in a folder, I could iterate over those, or have more complex restores in a single file. Or if you love DBA tools like I do, you could have PowerShell and DBA tools in the container image, then run something like restore DBA database to blow back or restore a collection of databases. And so that's what that script does. Let's find our second Docker data file. There it is. And so those scripts will get copied into that directory. We'll mark them as executable, expose, MSSQL server. And now you can see what's different here at the bottom. We have a different command instruction. We're going to execute that script. And then we're going to background that execution and then launch the SQL Server process. And so what happens here is the script will kick off. It'll start testing SQL Server. SQL Server will start. Once it's available, then the restore kicks in. So let's go ahead and in demo 2, jump ahead and do that build and deploy. It's going to run that code. So there our image SQL demo 2 is built. We're going to attach a volume this time, right? Because we want to persist our data from var opt MSSQL in a Docker data volume. But I'm going to use a bind mount this time to expose the base OS into the container. And so inside of this directory is where my backups live. In fact, if I grab this exact code here and pop it down here at the bottom and do an ls, you can see I have two backups in there, testdb1 and a tpcc backup. That's going to be available inside the container at this location. And so that's really the key difference between a bind mount versus a Docker data volume. A Docker data volume is going to be in that var, I think it's like var run Docker in a fixed location in the underlying OS as a managed element of Docker. Our data volumes, or excuse me, our bind mounts are basically just a way for me to expose data into the OS. I chose a bind mount here just to show it to you from a demonstration standpoint. This certainly could be a data volume too. So that container that starts the automated deploy process is now coming online, right? And I can follow the process of its initialization with Docker logs, the name of the container, and this -- follow command. And so what we see here is the output of the SQL Server error log. And if everything goes well, in a few moments, we're going to see the restore operation kick off for our instance, or for our database, excuse me. There we go. We can see restoring database, right? Let's go ahead and bring that in the screen. So my script says outputs SQL Server ready. Then we see it starts the restoring of the database. That's my output. Now we can see the actual error log entry that says testdb1 is marked for restoring. And then we can see that it actually restored the database. So since I'm using the follow option here, I'm going to use Control-C to break out and give me my terminal back. And so that at deployment time, right, I just started up that container from the image that we built together, now automatically restored testdb1 into the database without having to carry the weight of that data, right? It wasn't in the image. It just, I attached the backups, the script started, when the container started, found the backups, ran the restore. So let's look at that inside of the file system or inside of the container. If I go inside of the container and I look at that directory, it's the same as if we saw it a second ago in the base OS, right? Those are the same exact files, just exposed at this backup location. Our scripts, however, were copied into the container. So these will go along with the container at deployment time. So if you do need to make a change to those scripts, then the container will need to be rebuilt. However, there's probably some ways you can parameterize that as well to make that a little more sophisticated and dynamic if needed. We also see a slight difference in the instantiation here. We see that this script is called first, and then SQL Server starts up, but that script finishes, and all we're left with is the two SQL Server processes as expected. Excuse me. So let's go ahead and remove that container. Oops, exit out of the container. And then remove the container and then remove the volume. Cool. All right. Let's see. We got about 17 minutes left. It's a good amount of time. All right. So that's automatic restores inside of a container at runtime. Come on, computer, give me the right screen. Right screen. There's the right screen. Cool. So we restored some databases inside the container. All of the demo code will become available to you. In addition to doing the automated restore, in that same demo too, I have a manual restore where we're just executing that code manually. All right, so let's talk about more not say advanced topics, but kind of the next topic in performance management when you're running SQL Server in containers on a host, right? And we're going to look at multi-instance container scenarios for SQL Server on Linux. So when working with SQL Server on Linux, it doesn't support named instances, right? And as a Windows person, you might be thinking, well, I might want to have a couple of instances deployed on a single virtual machine or physical machine in my environment for whatever reason, right? But SQL Server on Linux doesn't support that because containers will provide effectively the same functionality for you. And so what we can do is we can deploy a collection of containers as long as they have unique container names, right? Storage for their data, unique network ports, then we can start kind of emulating that same named instance paradigm. And so let's see that in action. So if I deploy a container image like we've been doing, right? I just say, give me a container, run it on port 31443, which we've done, and allocate a data volume of SQL Data 1. Well, I can come along and run another container, right? Just on a unique name, so SQL 2, on a unique port 31444, and then with a unique data volume for it to store its data in. And I can kind of repeat that pattern over and over and over again, as long as I have enough resources on the base system that I'm deploying the containers onto. And so that leaves us with this statement: resource management is your responsibility. And what I mean by that is we need to set up, potentially need to set up some configuration to make sure that all of these instances are playing nice together on that base OS, because that base OS has some finite resources. I want to make sure that I'm allocating those or sharing those correctly amongst those container images. And that's really the concepts behind this next portion of the talk. We're going to talk about some container-based performance concepts so that we can help control those workloads that are deployed in those multi-instance scenarios. When you're deploying containers, what you're really doing is sharing the underlying OS and its hardware, right? So there's a finite amount of stuff, CPU, disk, and RAM inside of this physical or virtual system that I can allocate. And what we're doing when we start containers on top of that is just sharing that amongst the applications that are running. And so we need some way to control resources that are being consumed by processes that are running on that base OS. And that's where control groups come in, or C groups. Control groups are a function of the Linux kernel that allow me to put some boundaries or limits around what's getting consumed, right? And Docker allows us to control access to those resources via control groups. And so we'll look at a collection of Docker concepts and also commands that allow us to control access to resources when we start up a container. But under the hood, it's control groups and the Linux kernel that are controlling those controlling access to the resources in Linux-based Docker deployments. What can you control? CPU, memory, block IO, and the number of process IDs allocated. What's cool about allocating or system, what's cool about persistent or performance management with Docker, and unique to other concepts in Docker, is I can adjust these resource constraints at runtime, versus oftentimes most of the Docker settings that are set for a container are instantiated at startup time. I start this container, it looks like this, but I can adjust these after the container creation, which you'll see in our upcoming demos. Super deep topic here. I'm going to kind of go over it in some detail, but not crazy detail. Here's a link here if you want to dive into much more detail about how this all works under the hood. We're going to kind of focus on how this works and applies to SQL Server in this session. So when we want to limit CPU, right, we can limit CPU in a collection of ways. We can limit it by this concept called CPU sets, which will limit the container to a subset of processors. So I could say, you know what, this container here can only use processors 0 and 1, or 2 and 3, or 4, 5, and 6, whatever it is, right? Now, limits influence scheduling. So I can say, you know what, this container can only use one processor. And what that's going to do is schedule that processor or schedule that container such that it only uses one core's worth of CPU. And I say it like this because it doesn't limit it to one core. It's one core's worth of CPU. Shares will kick in when the CPU gets constrained. So basically it's limits, but they don't start coming into play until there's already some resource constraints. Here's what's unique about all of these different CPU limiting configurations is SQL Server will always see, or any process really, will always see all of the CPUs that are available at the base operating system. So my demo machine here has 2 cores in it. It used to have 6, but that's the one over there that caught on fire on Tuesday. This demo machine that I'm on now only has 2 cores in it. SQL Server will see those 2 cores, regardless of which configuration I set. If I use a CPU set and say you can only use core 0, SQL Server will still see all of the cores. The scheduler will affect the change that it requires me to run just on that one core. Same thing with limits. If I have 2 processors in my base OS and I say you can only use 1 core's worth, SQL Server will still see 2 cores, but the scheduler will balance it across both cores, but limiting it logically to accessing 1 core. And same thing with shares. And so if you configure a limit and you see access to all of your cores, you see SQL Server at the instance level can see all of your cores, that's okay. It's the scheduler that's going to affect that change for you, or affect that limit for you, I should say. Now, memory limits are real limits. If I say you can only have access to 8 gigs of RAM, SQL Server will only see 6.7 gigs of RAM. You're like, what? Why is that? Because of the architecture of SQL Server on Linux. When you start a container with, let's say, an 8 gig limit, the container will see 8 gigs. The SQL Server process sees 80 by default, will see 80% of the system memory that it has access to. So if I set a limit of 8 gigs, that's going to be the container of 8 gigs. The SQL Server process will allow SQL Server to allocate 80% of that, which is like roughly 6.7 gigs. If you don't set a memory limit, SQL Server will have access to all of the memory on the base OS. And in a multi-instance scenario, you can see why that would be bad, because they'll start fighting for the underlying memory. When it comes to configuration best practices for SQL Server, especially SQL Server on Linux, check out this link here from Microsoft. When you're performance tuning SQL Server, especially to run on Linux, if you want to really go beyond the basic limiting factors, you really want to eke out that last mile of configuration, you're just going to be doing Linux performance tuning, because in the end, these containers are running as processes on the base OS. So they might think that they are the only thing running on the system inside the container, but in a second, we're going to look at from the OS level, we'll see a bunch of SQL Server processes running, and we want to be able to make sure that they have access to the resources in the most efficient way. And that link there will teach you how to go that next mile for configuration best practices. Now, before we get into the demos, I want to talk about monitoring, like, because now we're talking about performance, and I want to be able to have these limits and things like that set. I want to be able to check, like, verify that these things are actually set, and that's where these monitoring concepts come in. I alluded to this earlier about the host name of the container affecting the server name metadata inside of SQL Server. When SQL Server starts up the first time, it's going to read the host name in the container environment. And that host name is going to match the container ID, which is volatile. In fact, if I delete the container and recreate it, I'm going to get a new container ID. But that very, very first time that container started up, it read the host name and stored that as the server name metadata. So we want to stabilize that host name at container startup time. And so I'll show you some syntax on how to do that. When you do that, that really enables third-party monitoring scenarios, because now you can just query the DMVs like they would be in any other SQL Server instance on a stable host name, right? Or server name metadata inside the OS. But a lot of third-party monitoring tools do rely on WinRM or DCOM or RPC to extract Windows perf data. Well, it's not Windows, so your mileage may vary there. For today, we're going to use Docker Stats, which is some Docker tooling to show us the performance utilization of the underlying system. And so we'll dive into that in the demos. Now, metrics are exposed by Docker that you can programmatically query and push into a monitoring system like Prometheus or Grafana to get some more advanced persistent metrics about the performance of your system. But in the end, it's still just an operating system running processes. So just monitor the base OS and you'll get it for system performance data. SQL Server you'll pull from DMVs, but monitor that base OS for system performance data. And one final point that I had to throw in somewhere, I couldn't quite figure out how to work it in. is when you start up a container, you have the ability to define a restart policy to help keep that container online if the container goes down or you restart the system. And so we can define a restart policy with 5 different attributes. No, which means just don't, and that's the default. And so you've probably done Docker run, rebooted your system, and then you have to go do Docker run again. Well, if you run a restart policy of on failure, well, if that container crashes, it'll automatically get restarted, right? Or always, if that container shuts down, regardless of how it shuts down, it'll get restarted. Or unless stopped, it'll always restart that container, whether it's crashed or the system rebooted, unless you came along and said Docker stop. And so those are pretty valuable ways to keep that container online outside the lifecycle of your underlying OS or the processes itself. And so let's get into our final demo and look at how to set the host name and examining some performance data. All right, let's jump over here. Let's bring up demo 3 and change into the right directory, demo 3, clear this up. So I'm going to start a container with no limits. So there's no limits defined, but I am defining a host name. And so this is how we can define the host name inside the container. And so the first time SQL Server starts up, it's going to read that value and set that in the server name metadata. So now when I come back and create new containers, rather than trying to use the container ID, it'll have a stable host name. And I also am going to do a restart policy of unless stopped. So and we're also going to run our very first container image that we built together today. So our custom container image. So now if I do a Docker PS, we can see the container ID ends in 180. It's going to take a second for that SQL Server instance to start. Come on, SQL Server instance. There's a login failure there we go. So I'm just querying at server name, and we can see that rather than it being the container ID, it's a fixed server name now. So let's query some system information from DMOS sysinfo. So one, I want to point out that we can query DMVs, no big deal. But now I'm going to pull the what SQL Server thinks it has access to. So the CPU count, it thinks it has access to both cores and to 6 gigs of RAM. The VM itself has access to 8 gigs of RAM. So 8 gigs of RAM times 80%, because that's what SQL Server will expose, or SQL PAL will expose into the SQL Server process, is approximately 6%. Or excuse me, 6 gigabytes. Looking at Docker stats, there's our container, there's its name, and this is its current resource utilization. It's using about 6% CPU, about 750 gigs of RAM of a total of 7.7 gigs. The system has 8 gigs of RAM, but it's rounding off a little bit there. And then you can see it's about 10%. We can track network IO, block IO for both read and write, and the number of PIDs that have been allocated altogether inside of that system. So let's start up a container with a host name. This time it's 3B. It's a second container that's running on my system. I'm going to start it up with a memory limit and a CPU limit, and I'm going to publish it on a different port. And so now that's an example of that multi-instance container scenario. Run that. I have a warning right now because my base operating system doesn't have a swap file. That's intentional for some other work that I'm doing, but you likely won't see that on your system. So if I do a Docker PS now, I see I have 2 instances that are up and running. SQL A on 341.31433 and SQL B or 3B on 31434. I need to pick more ports that roll off the tongue a little easier. So now if I query that same data about that second instance that I stood up, I'm going to query the same information that I queried a second ago, but the difference is I have a memory limit and a CPU limit this time. I should just write a loop for this like the other in the second demo. So I have a memory limit of 4 gigs, but I see access only to 3 because of the whole concepts of SQL PAL. And I have access, even though I set a CPU limit of 1, I still see 2. I wanted to point that out there. So let's see that in action. I'm going to kick off a workload and see how it affects that CPU limit when it's running a workload. So this workload basically creates a database and inserts a bunch of data. So it's pretty nasty from a performance standpoint. I'm going to, in this other window here, increase the font size substantially and run a Docker stats. And so what we see here is the system is using about 20% of the CPU, so less than 1 core is being allocated. We see our memory limit is affected with 4 gigs of RAM. Remember, SQL Server only sees 3 of that, but the container, the whole container, has access to 4. And since I'm running this workload, we can also see that almost 3 gigabytes of data has been written. So there's 3 gigabytes of data. So let's affect some changes. So here we can see I can reduce the CPU limits to half a core. Let's go a little bit further to just 1/10 of a core and see the impact of that. So a moment ago, it was in the mid 20s. Now it's down into 10%, about 1/10 of a core. And so even though SQL Server sees all of those processors, it's the scheduler at the OS level that's dealing with that and making sure that it's limiting the access to the underlying base OS. Now, I do want to point out that these are just processes running on the base OS. So this is on the base operating system. We can see inside of here, off of container D, are SQL Server processes. So there's the one SQL Server we have up and running, and there's the other SQL Server we have up and running. And these are the process IDs associated with that, even though inside the container, they start off with process ID 1, and usually SQL Server winds up with a process ID of 8 or 9, depending on how you started the container. If you want to figure out which process ID out here is which process ID inside of the container, you can use the docker inspect command for that. So if I do a docker inspect SQL demo 3b, pipe that into more. Inside of here, you'll be able to see the actual process ID of the underlying process. So that's how you can connect the two from a monitoring standpoint, because that process ID matches the container name. Whereas if you're looking inside the container, it's just going to be process ID 7 or 8, depending on how SQL Server was started. So let's kill that workload before this laptop that's my backup laptop gets a little sadder. Kill that workload, okay? And delete our containers. And jump back into the presentation. I can really hear my CPU fans now. My laptop is not happy. So, come on, there we go. So we looked at how SQL Server sees that host hardware with the context of limits and non-limits, right? For that first container, we started up with no limits. We looked at how we can use Docker stats to examine that performance data to see who's consuming what, that the impact of applying a CPU limit to a workload, where that workload went from using a little bit more than a 25% of CPU down to 1/10 of a CPU when we affected that change. Now, that was just a CPU limit. Of course, we could have applied sets or shares in that scenario too. And we also saw how memory limits actually limit the amount of memory exposed into the container, and then how SQL Server only sees about 80% of that. What I didn't cover is in large memory scenarios of SQL Server on Linux, that 80% number starts to fall down a little bit. And so if you have, hundreds of gigabytes of RAM or terabytes of RAM, that 20% starts to become a little bit wasteful, in that you could allocate more than 80%. And you can use MSSQL-conf to affect that change. In that best practices document that I linked to, Microsoft goes into a little more detail about that. So to wrap it up, we looked at storing persistent data in containers, right? What that really, really means under the hood, at the container level and also at the base operating system level. And I showed you where that data really lives when we deploy it from the base OS. And that can be either local storage, which it was in our scenario today, or remote storage. We looked at what it means to run a non-root container and why that's super duper important because of privilege operations, et cetera. But if you're running a modern image of SQL Server, official image, that's going to be non-root. But if you're building your own images, you want to make sure that it's running as non-root. And we looked at how to do that when we got into the section where we built our custom container image. In that section, we also looked at how we can add additional features by installing additional packages like ML. We kind of discussed it, but I didn't show it. But also how to inject configuration with the tools that we have available, either MS-SQL Conf or environment variables. We looked at how to get data into our containers, leveraging either data volumes or bind mounts, and then doing an automatic restore at container deployment. You can also attach to, if that's what's needed for your scenario. And then you can take that script and extend that to do more advanced stuff. But that process of looping to check if the instance is online and then running the script is really the way that you want to get that process started. And then we dug into some container performance concepts and what it means to run multiple instances on a system. And we looked at some of the basics on how we can assert some limits to control what processes have access to what. And then we touched on some basic monitoring concepts so that we can query that information either using Docker stats or at the base OS level inside of Linux with the tools that we have available, and how to connect to which process in a container is which process ID on the real base OS. I'll take this presentation in the next few minutes and I will turn it into a PDF and take all of the code and put it on GitHub, and you'll find it there. There's my contact information. If you have any questions after today, please feel free to reach out. If you're not following me on Twitter already, please follow me on Twitter. It's kind of my main way to interact with the community. And thank you. Thank you so much. Is there any questions for us?
Thank
Amit?
you. Thank you, Anthony. Great session, great set of demos. And I think the audience loved it. You had 84 people in the room.
Oh, cool.
Yes. So, and there are questions too. So let's get started. The first question is from Christian. And his question is, which one you suggest for container orchestration, Kubernetes or Docker Swarm?
So it's Kubernetes. The joke that I like to make about that is, remember like beta and VHS or DVD and Blu-ray? Well, somebody won those, let's say like video wars, Blu-ray won over DVD, and VHS won over beta, depending on which generation you are. Kubernetes won the container orchestrators war and has become the de facto standard. If you have either Docker Enterprise or Swarm, certainly you can use that as a tool. The concepts are all the same, but in implementation, Kubernetes is the thing. And if you're looking for like an off-the-shelf package, OpenShift, and there's a bunch of other players in that game as well that are doing the container orchestrator game.
Thanks, Anthony. Christian, I hope that answers your question. The next question is from Daniel, and his question is, how do you integrate Docker Compose with AWS code build?
So that's not something that I have a lot of experience with, but I can maybe check into that a little bit. So AWS code build and Compose. A friend of mine does a lot of work with Compose. And so if you do have a question specific about that, I can put my contact information back up here for you. Sure. I can dig into that in more detail.
Absolutely. So Daniel, feel free to connect with Anthony on the coordinates mentioned on his slide, and maybe in a few hours or in a few days, Anthony might have an answer for you. He keeps quite busy. So yeah, good luck with that. Okay, so we have just 5 more minutes in the Q&A time. If there are more questions, please use the chat window on the Connex platform, and we'll bring it live into our setup here and ask questions.
So yeah, this was the first time for this session, Amit. So yes, it was funny. I gotta just fill some air, I guess, for the next few minutes. If you need to interrupt me, please feel free to. I got everything sorted to present the pre-con on Tuesday. Then yesterday I was going to do a dry run of the presentation, and my OneDrive had failed to replicate the directory that this presentation was in into Azure or into OneDrive. And I was like, I need to find this presentation. So luckily I have 2 levels of backup. I was expecting OneDrive to do its job. It didn't, but I had another backup. So I had to go and configure this system to access those backups. And finally I pulled it down. And so at like 4 o'clock yesterday, it was 4 p.m. my time. I was able to kind of piece everything back together for today.
Man, yeah, too many things going on. That is in addition to your burnt laptop.
Yeah, it's been a crazy time. So
crazy time. All right. I do not see any more questions, Anthony. So we may end the session now.
Okay.
Unless you have any final words for the audience and for DPS team or anything.
Audience, thank you so much. DPS, thank you so much. The community that you've built has been fantastic. The conference so far has been amazing. So thank you so much for all of your efforts, everyone.
Thank you. Thank you, Anthony. Thanks, audience, for joining this session.